All right, the last part of this section, we're going to talk about more applications involving slope. In this presentation, we are going to be looking at some new topics. This is going to take stuff that we know and apply it to stuff that we are going to see in future math classes. All right, so let's start off with slope. Slope is something that we've been playing around with for quite a while. And remember that slope is our m value in our slope-intercept form. But we can also go ahead and calculate slope if we have 2 points. And so remember that m is equal to the change in y over the change in x, the rise over run. And that triangle symbol, that just means change. And so to calculate slope, we do y2 minus y1 over x2 minus x1, given any 2 points on a line x1, y1, and x2, y2. Now when we use the term slope, we are talking specifically about linear equations. However, we can extend this concept and we're going to talk about an average rate of change. And an average rate of change is we are going to be given a function and 2 x values. Now notice here that function, it can be any kind of function. It can be linear, it can be quadratic, it can be rational, it can be radical, anything like that. And so what we do is, one of the things I do want to point out is we are still using our formula for slope, but we're putting it in function notation. So notice here, y2 is the output for x2. And so if we write this point in function notation, we basically replace our y2 with f of x2. And similarly, y1 is the output when we plug in x1. And so we replace y1 with our function notation, which is f of x1. All right, so we call this average rate of change because our function may not be linear, so we cannot use the term slope. So what we're going to do in order to do this is we want to find our 2 points. So we are going to start by evaluating the function given the 2 x values. We write them as points, and then we plug them into the formula for slope, or the formula for average rate of change. This is something that we'll see in this class. We're going to see it in the next class, and this is a really important topic when we get into calculus. And in calculus, what we do is we refer to this as a secant line. All right, so let's go ahead and look at some examples of this. Okay, we have a couple functions here, and so we're going to go ahead and find the average rate of change. And so again, the first thing that we want to do is we want to find our points. We're going to start with a linear function, and let's see what happens. If we plug in -3, we get f of -3 is equal to 4 times -3 minus 3. And if we simplify this, we get -12 minus 3, which is equal to -15. All right, so that's our first one. All right, we want to also plug in 1. And if we plug in 1, we get 4 times 1 minus 3. This is equal to 4 minus 3, which is equal to 1. And so we have f of 1 equals 1. Okay, so you can approach this problem from two different perspectives. You can either use your average rate of change formula. If we do that, we have f of negative 3 minus f of 1 over negative 3 minus 1. Again, remember that when we talk about slope, it doesn't matter what order we put this in, as long as we are consistent with the top and the bottom. So if we plug this in, we get negative 15 minus 1 over negative 3 minus 1. And what this is equal to is negative 16 over negative 4, which is equal to 4. Now, we knew that because this was a linear equation. Remember, average rate of change is basically a slope. And when we are talking linear equations, well, that's what we're given. We are given the slope. Now, if you don't want to memorize new formulas, we can go back to just what we did before. And so we have our functions, and we can rewrite these functions as points. And so, for instance, f of negative 3 equals negative 15. Well, that means that we have a point on our graph of negative 3, negative 15. And we have another point of 1, 1. And then what do we have here? We have, again, I did it backwards. Doesn't really matter, as long as we are consistent. And so we can go ahead and plug these in to our formula for slope, x2, y2, x1, y1. Again, it doesn't matter what order we put this in. And if we plug these in, we do get the same thing. We get negative 15 minus 1, negative 3 minus 1, and we've basically calculated our slope given 2 points. All right, now, this is a linear one. We went through a lot of work to basically show that the slope of the line was 4, which we didn't have to do because, well, it's a linear equation and it has a slope of 4. Now, when we move into other types of equations, then this is necessary. And so, for instance, f of x equals 2x squared. This is not a linear equation. And so we do have to find the average rate of change. Now, it's up to you how you want to think about this. Me personally, I don't like memorizing formulas unless I have to. And you don't have to memorize average rate of change formula. You can go ahead and just use your formula for slope. We just have to start by finding our 2 points. All right, if we come to example B, we have a function 2x squared. And so if we plug in our numbers, we want to know what is f of 1. F of 1 is equal to 2 times 1 squared. And if we simplify using order of operations, we square the 1, which is 1, multiply times 2, and we get 2. All right, if we calculate f of 3, we plug in 3 for x. We simplify using order of operations. We get 3 squared is 9. And if we multiply times 2, we get 18. And so my 2 points are 1, 2, my x and my y. And we have another point 3, 18. We have x is 3, y is 18. And then we can find our slope. So we're going to do y2 minus y1 over x2 minus x1. We get 16 over 2, which is equal to 8. and you're done. All right, let's come to example B. Same thing. If we plug in -4, we get f of -4 is equal to 2 times -4 squared. If we square -4, we get positive 16. Notice here you do need the parentheses when you plug in the negatives. And so -4 squared is positive 16, and if we multiply it by 2, we get 32. If we plug in -2, we get 2 times, and again I do want parentheses around this. If we square -2, we get positive 4, and if we multiply that by 2, we get 8. So my 2 points are -4, comma 32, and -2, comma 8. All right, if we go ahead and find our slope, we want to do y2 minus y1. We want to subtract our y coordinates over subtract our x coordinates. We have -2, we have minus -4. Remember that when you subtract a negative, we want to change it to a plus sign. And now, if we go ahead and simplify this, we get -24 over 2, which is equal to -12. All right, to kind of show you what we're doing when we talk about this is when we talk about average rate of change, what we have here is we basically have a graph of a parabola, and remember that all parabolas have this basic shape. And what we're doing is we are plotting 2 points. For instance, on the left side, 1 to 3, we are looking at these 2 points and we are finding the line that goes through them. On the other side, we have -4 and -2, and this is just a rough sketch. But if you notice, we have a negative slope, if we call it slope, on the left side, which means that it's going down from left to right. When we look at from 1 to 3, we're on the right side of the parabola, and we are going up from left to right. All right, let's look at one more and see what we can do with it. All right, example C. We have let f of x equal the square root of x plus 5. We want to find the average rate of change. And so if we go ahead and do the same thing, we want to start by finding our function values. So if we plug in 4, we get the square root of 4 plus 5. This is equal to the square root of 9, which is equal to 3. If we plug in 7, we get the square root of 7 plus 5. This is the square root of 12. And so we get f of 7 equals the square root of 12. Now, that's probably not going to help us when we want to find average rate of change. So let's go ahead and approximate this. If we go ahead and approximate this, we have the square root of 12 is approximately 3.46, and you'll want to go ahead and make sure that you double check how many digits you want if it's asking for an approximate value. I'm going to go out to 4 just to be on the safe side. All right, so we have our 2 points. We have 4 comma 3, and we have 7 comma 3.4641. If it asks for an exact value, then you do want to leave it as square root of 12. All right, so when we plug this into our formula for slope, we get 3.46 minus 3. We subtract the y value. And we want to divide by, subtract the x values. And so what we get, if we subtract on top, we get 0.4641 divided by 3. And this is approximately 1 point, no, sorry, I forgot to subtract. I get 0.1547. All right, let's do one more with our average rate of change. We have x equals -1 and x equals 0. If we plug in -1, we get the square root of -1 plus 5. This simplifies down to the square root of 4, which is equal to 2. If we plug in 0, we get the square root of 0 plus 5, which is the square root of 5. And if we approximate this, we get the square root of 5 is approximately 2.2361. All right, so my points are -1, 2, and we have 0, 2.2361. If we go ahead and calculate our slope, we want to subtract our y values, 2.2361 minus 2 over, subtract our x values, we get 0, minus -1 becomes a plus 1, and this is equal to 0.2361 divided by 1, which is 0.2361. All right, so that is average rate of change. All right, so we have talked about our average rate of change. We've talked about slope. The last thing that we want to talk about is difference quotient. This is a topic that is going to be one of the fundamental concepts in calculus if you go that high. All right, so let's talk about how is this related to our formula for slope. What we're going to do is, instead of looking at specific x coordinates, we want to think of the first point as just being a point with an x coordinate of x. The second point is going to be moving away from the first coordinate by a value of h. So we have our first point is going to be x and f of x, just like we had when we talked about our average rate of change formula. Our second point, what we're going to do is for our x coordinate, we want to add h, and then we're going to plug that into our function and have f of x plus h. All right, from here, what we have, in order to do this, we want to plug in x plus h to the function and simplify it. We want to apply exponents, we want to distribute, we want to combine our like terms, and then we are going to subtract f of x. Now, one of the main things you do need to remember is make sure that you remember to distribute the negative to all the terms. If you do this correctly, you should get that like terms can be canceled out. We should have lots of terms that cancel. What you should be left with is all of your terms should have an h in them. And we're going to divide the remaining terms by h. One thing to note is this is a difference quotient. This is not the original function. So make sure that when you are done simplifying the entire thing, we do not set equal to f of x. You just leave it. It is an expression. There should not be an equal sign in your final answer. Now, when we talk about slope, remember that to find a slope, you have to have 2 points. Now, when we work with the difference quotient, what we can do is after we simplify this entire thing, we can plug in 0 for h. It's not going to be undefined. And we can find the slope at a single point. All right, so let's go ahead and look at some examples of this. All right, we are going to find the difference quotient for all sorts of different things, all sorts of different types of functions. All right, let's go ahead and start with our base case. Remember, difference quotient is essentially a slope. And so, for instance, on example A, we're going to do a lot of work just to show that the slope is 3. All right, so let's start with f of x equals 3x minus 2. So we have our formula again. Don't worry, you are not going to be required to memorize this formula. You will be given this formula in this class, but it is one that you will need to memorize at some point. All right, so we have f of x plus h minus f of x over h. Okay, the first thing I want to do is I want to find f of x plus h. So just like when we plug in numbers, we are just going to take this expression, we are going to plug it in for our variable. And so if we plug this in, we get 3 times. We're going to replace x with x plus h. And we bring down the rest of our equation, we have minus 2. All right, we want to simplify this, so we don't want any parentheses. We're going to distribute, so we get 3x plus 3h minus 2. And it doesn't simplify any further than that. Okay, so we're going to come over to our difference quotient now. This expression is our f of x plus h, and so we're going to put it in the first thing. So we get 3x plus 3h minus 2. After that, we want to subtract f of x. So we want to subtract this entire expression. And again, remember that we want to distribute the negative. And so we want minus 3x minus 2. We're going to put this whole thing over h. All right, if we distribute the negative to the second set, we bring down our 3x plus 3h minus 2. And when we distribute the negative, we get minus 3x plus 2. We still have this as over h. And then we want to cancel common factors, or common like terms. So we have our 3x's cancel. We have our 2's cancel. And what we're left with is 3h over h. We can cancel our h's, and lo and behold, we determined that the slope of the line is 3. And we're done. Now, for the rest of these problems, we're going to have an expression here, and we leave it just like that, okay? Difference quotient is rarely, it's only going to simplify down to a number when we are looking at a linear equation. Because the rest of these do not have a constant rate of change, because they don't have a slope, we will have something more complicated than a 3. All right, let's come over to B. We have f of x equals 3x squared plus 4. And so again, we have our difference quotient is f of x plus h minus f of x over h. Okay, if we find f of x plus h, remember that we want to plug in x plus h for x. When we do this, we get 3 times x plus h squared plus 4. Now, if you've taken my previous math classes or if you've watched my videos before, remember I don't like memorizing formulas. But right now it's a good time to remember what x plus h squared, what a binomial squared is equal to. So this is equal to 3 times x squared plus 2xh plus h squared. Okay, why is that? Well, remember that when we square a binomial, what we actually want is we want the binomial times itself, and we do have to FOIL it. So if we FOIL this, we get xh for our outsides. We get hx or xh for our insides. And we get h squared for our lasts. So this does simplify down to x squared plus 2xh plus h squared. As we're going to be doing this a lot, I do recommend memorizing this formula at this stage so that you don't have to FOIL it a lot. All right, if we finish simplifying our difference quotient, we want to distribute the 3 to all of these terms. So we get 3x squared plus 6xh plus 3h squared, and then we have our plus 4. All right, we're going to go ahead and plug this into our fraction. So we have f of x plus h was 3x squared plus 6xh plus 3h squared plus 4. And now we want to subtract f of x. So I don't have to write this a bunch of times. Remember, we do want to distribute the negative. So if we distribute the negative, I want to subtract 3x squared, and I want to subtract 4. We have our h on the bottom, and then we want to cancel like terms in the top. So we have our 3x squareds cancel, and we have our 4s cancel. Everything in the f of x should cancel out. And notice here that what we are left with is 6xh plus 3h squared all over h. All of these terms have an h, and so they can cancel out. So we can cancel an h from the first term. We can cancel an h from the second term, but we will still be left with an h. and then we can cancel the h in the denominator. And so what we are left with, our difference quotient, is equal to 6x plus 3h. And we're done. All right, let's look at some other examples that are a little bit more complicated. All right, let's come to f of x equals negative 6x squared minus x plus 4. We have our difference quotient again. F of x plus h minus f of x. I know that you're probably wondering, why am I writing this out over and over and over again? Well, for me, this is the easiest way to memorize a formula. Okay, so let's find f of x plus h. Notice we got a square here again, so this is one of the reasons that I do recommend memorizing this formula, because we have a lot of stuff to write out as it is, and I don't want to FOIL it again. All right, so this is what we have. We plug in x plus h wherever we see an x, so we are plugging it in here, here, and of course over here. All right, if we square our x plus h, this is x squared plus 2xh plus h squared we want to distribute and clear our parentheses. So we get negative 6x squared minus 12xh minus 6h squared. We also want to distribute our negative to the second set, so we get minus x minus h, and then we still have our plus 4. Okay, I really don't feel like writing this again. So we have our f of x plus h, and then I want to subtract my f of x. So we want to, remember we're subtracting, so we want to distribute the negative. We should get plus 6x squared. We distribute the negative to the second term, we get plus x. And we distribute the negative to the last term, we get minus 4. And we are going to put this all over h. All right, if we cancel out our like terms, we can cancel out the negative 6x squared. We can cancel out the x, and we can cancel out the 4. And what we are left with is negative 12xh minus 6h squared minus h over h. All right, if we cancel an h from each term, the h goes away in the first one. In the second one, we are going to change this to a 1, and the h cancels out from the last one. Now be very careful with this last term, because remember what this is basically equal to is minus 1h. There is still a number there in the front. So when we cancel it, we do still have that term there. And we can cancel out the h from the bottom. And so what this is equal to is this is equal to negative 12x minus, negative 12x minus 6h minus 1. Most of the time in this class, we are going to be playing around with polynomials and pretty much the quadratics. But we can extend this idea to the harder ones. So let's look at a rational one just to kind of switch it up a little bit. All right, we have our function again. We have f of x plus h minus f of x. And when we find f of x plus h, this is equal to 1 over 2 times x plus h, which is equal to 1 over 2x plus 2h. Sorry, I forgot the rest of my difference quotient. Okay, so let's see what we can do here. So we're going to start by going ahead and plugging in our f of x plus h. We have 1 over 2x plus 2h. We want to subtract the original function, 1 over 2x. And we want to divide this whole thing by h. Now, if you remember when we talked about fractions, if you want to avoid complex fractions, what we can do is instead of dividing by h, we can multiply by 1 over h. I don't like complex fractions, so this is my way to kind of avoid them. Okay, so now what do we do from here? So from here, what we need to do is we need to rewrite the inside as one fraction, so we do need a least common denominator. Now, these denominators are not the same, and so my least common denominator is going to be the 2x and the 2x plus 2h. So this is going to be my LCD, 2x and 2x plus 2h. All right, my first fraction, I have the 2x plus 2h. I don't have the 2x, so we're going to go ahead and put that on the top. My second fraction, I have the 2x. I don't have the 2x plus 2h, and so we are going to subtract 2x plus 2h, and again, I'm going to go ahead and distribute the negative to get rid of it. So that we don't have to do this in 2 steps. So I'm going to subtract the 2x, I'm going to subtract the 2h, and then we have all of this is multiplied by 1 over h. All right, now we can go ahead and cancel things out. So we can go ahead and cancel our 2x's. We are left with negative 2h over 2x times 2x plus 2h times 1 over h. From here, we can go ahead and cancel out our h's. We can cancel out the h in the numerators and the h in the denominator. And what we are left with is negative 2 over 2x times 2x plus 2h. Now we can cancel one other thing. We can cancel the 2. And so if you want, you can distribute first, but I'm going to go ahead and just cancel right here because everything is being multiplied. And so what we are left with is negative 1 over x times 2x plus 2h. If you want, you can go ahead and distribute the x. It's not going to really matter. This way I would say is considered acceptable. If you want to distribute it, then we should have negative 1 over 2x squared plus 2xh. All right, that's going to be kind of our challenge problem here. Again, we're going to primarily focus on polynomials, and we're really going to focus on the quadratic to kind of keep it within reasonableness. This can be applied to cubics, and it can be applied to other ones, but that's where we're going to go ahead and kind of focus our energy. All right, I'm going to leave these last two for in class. And so we won't worry about these ones. I encourage you to try the last two on your own, but we'll go ahead and look at these in class. All right, the last thing that I do want to go over from this section is let's talk about our summary of what we mean by functions. So when we talk about functions, just some things to remember. Remember that when you are plugging in numbers for x, you will have only one answer because of the definition of a function. When plugging in numbers for y, or when being asked to find the x values, you can have multiple answers. If you are asked to do this, make sure that you list all numbers that satisfy the statement. In this section, we also talked about minimum and maximum points. And remember, this is the point that has the smallest or largest y-coordinate. If we are asked for a point, you do need to write your order as an ordered pair, x, y. On the other hand, if you are asked for a minimum or maximum value, then this is just the y-coordinate of the minimum or maximum point. Another thing to note is not all functions will have a minimum value or minimum or maximum point. If there is no minimum or maximum, then we just say none. We also talked about intercepts. Remember that the intercept, the y-intercept, is where the graph crosses the y-axis, and this is where x is equal to 0. All y-intercepts should be written as points 0, k. We talked about x-intercepts. X-intercepts is where the graph crosses the x-axis. This is where y equals 0, and should be written as k, 0. One of the things to note when you're being asked for intercepts, we usually talk about x and y, but when we get into application problems, we may be asked for a c-intercept or a t-intercept. And when we look for intercepts, we always plug in 0 to the other variable. So for instance, x-intercepts, we plug in 0 for y. Y-intercepts, we plug in 0 for x. Related to x-intercepts, we have zeros of a function. Remember, this is where the function is equal to 0, so where f of x equals 0, which is the same thing as where the y-coordinate is equal to 0. The difference between x-intercepts and zeros, if you're asked for the zeros, you do not write answers in point form. You only list the x-coordinates. Note, not all functions will have a 0 or will have x-intercepts, and so if no 0 exists, you can say none or no solution. The last thing that we talked about was where intervals where a function is positive. Remember that when we talk about positive, we want the interval of the x values, where the graph is above the x-axis. We use parentheses for numbers if it is on the x-axis, because x-axis is where it's equal to 0 and it is not positive. When we talk about where a function is negative, we want the interval of x values, again, where the graph is below the x-axis. Again, remember to use a parenthesis if the number is on the x-axis. We also talked about intervals where a function is increasing. Remember that the interval, this is where the interval of x values, where the graph is going up from left to right. We use a parentheses for all of these. We will never use square brackets, and we will use parentheses for both the leftmost and rightmost values. For where a function is decreasing, remember this is the interval of x values where the graph is going down from left to right. And again, we have to use parentheses for both the leftmost and rightmost values. And then we talked about where a function is constant. Remember, a function is constant. We want to list the x values where the graph is horizontal. It does not increase or decrease. It does not go up or down. And remember again, we have to use parentheses for the leftmost and rightmost values. All right, that finishes off A2. The next section, we're going to continue talking a little bit about linear and practicing some of these same concepts again. All right, thank you.